All right, so since our class is called Applications of Functions, I thought it would be good for us to spend a week reviewing some of the types of functions you guys have already learned in the past. And for today, we are going to start with what's called a linear function. Now, the word linear comes from the word line. So whenever you say something is linear, you're usually talking about a perfectly straight line, nothing that curves at all. Now, from the equation of a linear function, what you really want to remember is that linear means x to the first power, or basically just x with no exponents at all. If your equation has any exponents in it, if there's an x squared, or an x cubed, or an x to the 10th power, it is not a linear function. Now, the most common form of a linear equation is what we call slope-intercept form, and it's y equals mx plus b. Now, in that equation, the letter m stands for the slope of the line, and that's what I want to focus on for the rest of today's video. Probably the most important aspect of any line is its slope, so we want to make sure that we really understand how to find the slope of a line. So let's start off with this example right here. Let me just give you the equation of a line, y equals negative 3x plus 11. If I say, what is the slope? You don't have to do any work at all, because remember, I told you this is in what we call slope-intercept form, y equals mx plus b. And if the equation is in that form, then this number right here, m, is the slope. So the answer to this question, the slope of this line, is negative 3. So if the equation's in slope-intercept form, you know the slope just by looking at it. It's basically the coefficient or the number in front of x. All right, so here's a little bit more information about slope. There's 4 different things that we're going to kind of break into categories here. The slope can be a positive number. Now what you want to do is you want to think of a point moving along that graph from left to right. If that point is moving upwards or uphill, as I put in the picture here, we call that a positive slope. So that green line that you see there, that's an example of, we'll say that slope is about 1. Now, any positive number will be uphill like that, but the bigger the number, the steeper the hill. So like if I said that green line, let's say the slope is 1, if the slope was 2 instead of 1, what that would mean is it would still be uphill, but it would be a little bit steeper hill. And if the slope was 10, it would be much steeper. So basically, the positive part tells you uphill. How big the number tells you how steep it is. And then we have the same relationship for negative and downhill. So again, as the point is moving from left to right, if it's moving down, if it's dropping or moving downhill, that's a negative slope or a negative number. And again, I think that green line is about slope equals negative 1. If it was slope equals negative 10, then what you would have is downhill but very, very steep, something like this. That might be negative 5 or so. That's not even steep enough to be negative 10. But you guys get the idea. Any point that's moving uphill, that's a positive slope. Any point that's moving downhill is a negative slope. And the steeper that hill is, the bigger the number part of that slope is. Now, if you have a perfectly flat or horizontal line, it's not moving up or down, then the slope is 0. And the last one, this is kind of a tricky one. If you have a perfectly vertical line, a line that's up and down like a wall, what we call that is undefined slope, or we say that that line really doesn't have a slope. It's just perfectly vertical. So those last two, the slope equals 0 and slope equals undefined, are special cases that can be a little tricky, but these are the 4 possibilities for slope. So let's go back to finding slope. We talked about if the equation is in slope-intercept form, it's very simple. The number's right there for you. The second case I want to talk to you guys about is if you know any 2 points on the line. You know, that's a good rule for you guys to remember. If I know any 2 points on a line, I can real easily use those 2 points to find the slope. Now to do that, we're going to use something called slope formula. This may look familiar to you guys. You probably learned it at some point in the past, maybe in Math 3 or even junior high, Math 1 or 2. But basically the slope m, we're using that letter m always stands for slope. So when we had y equals mx plus b earlier and I said m is slope, same thing here. This m represents the slope. And then you have a formula which looks kind of confusing, y2 minus y1 over x2 minus x1. What that means, now remember, every point is always x comma y. That's how you plot a point. The x number comes first, that's how far you go left or right. The y part comes second, that's how far you go up or down. So when I say y2 or y1, remember we have 2 points. The 2 means the second one and the 1 means the first one. So basically on the top what you're saying is you're going to take the y part of the second point minus the y part of the first point. And on the bottom you do the same thing with the x's. The x part of the second point minus the x part of the first point. And if you do that, you'll get the slope. So let's try another example here. It says, what is the slope of the line that goes through these 2 points? The first point is 3, negative 4, and the second point is 1, 2. So basically, remember, each one of these, every point stands for x, y. But since we have 2 different points and we want to know which one we talk about, we'll say, well, that's my first point. So I'll call this one x1 and y1. And this point over here, which is also x, y, that's my second point. So I'll call it x2 and y2. And that's all those numbers mean. They're not, you're not multiplying by 2. It's not an exponent or anything like that. It's just a way of saying, this is the first x and this is the second x. So our formula from the last page was m for slope equals y2 minus y1 over x2 minus x1. And now just plug the numbers in. So from above, y2 is 2 minus y1, which is negative 4. And on the bottom, x2, which is 1, minus x1, which is 3. Now remember last week we reviewed all of our properties of integers. When you're subtracting a negative, it's actually adding the opposite, it's adding a positive. So instead of 2 minus negative 4, I'm going to think of it as 2 plus positive 4, which would be 6. And then on the bottom, 1 minus 3 would be negative 2. It's negative because remember, you're subtracting a bigger number from a smaller number. And 6 divided by negative 2 equals negative 3. And that's our slope again, just like our first example. It took a little bit more work this time. We didn't just see it from the equation, we had to figure it out. But that's an example of how slope formula works. y2 minus y1 over x2 minus x1 will always get you the slope of the line. All right, one last thing for today. If you happen to actually have the graph of the line, you guys probably remember learning something before where you did rise over run. Rise means counting the number of spaces you move up or down, and if you move up, it's positive, down is negative. And run is counting the spaces left and right. If you move to the right, it's positive, and to the left is negative. Now, what I want you to realize is it's basically the same thing. It's basically like the visual version of slope formula. So here's an example. We'll turn this into an example. Here's a graph. Here's a graph of the line. What I can do is choose any 2 points that I can see are definitely on the line. So let's say I'm going to choose this point right here, and I'm going to choose this point right here. And remember, you can pick any 2 points that are definitely on the line. There's several good choices in this problem. I just picked 2 of them. Now, to get from one point to the other, I'm going to go here. That's basically my rise. And then I'm going to go here, which is the run. And just count the number of squares. So when I do rise over run, number 1, when I do rise, remember, I didn't go up, I went down. and when you move down, that's negative. So the rise is actually -2. And then the run went 4 spots to the right. That's positive direction. So that would be +4. And my answer, if you reduce that, would actually be -1/2 for slope. So when you have a fraction, when you have a 2 and a 4, you have even numbers, you can divide both of those by 2. So -2/4, or -2/4, reduces to -1/2. Now real quick, just one other thing here. I just want to show you rise over run actually works either way. So like I started with the point on the top left and did rise over run going to the point on the bottom right. I could have gone the opposite way. I could have started at this point and gone rise here, run here. You'll get the exact same answer, because what happens if I do it the way I did it in blue right there? The rise is now +2 because it went up, but the run is -4 because you went to the left. And +2 over -4, it's still positive over negative, so my slope still comes out to -1/2. So you can see whether you did it the way I did it originally in red or the way I did it in blue, doesn't matter, do either one. As long as you're careful with the positives and negatives, meaning rise is positive if you go up and negative if you move down, and run is positive to the right and negative to the left. And as long as you remember those and you're careful with those, either one will work. All right, so that's a quick review of linear functions and mainly slope. We have an assignment to do, and I'll answer questions from it tomorrow.